My calculus class takes detailed notes. Okay, you got the cosine of 30 plus 60. True or false? That equals the cosine of 30 plus the cosine of 60.
Yes.
Yeah. True. True. I want to say
Well,
true.
I'm looking at it. Nope.
True.
Okay, well, we're going to actually check it because you know the values. Would you agree this is just the cosine of 90 on the left side?
So, yeah.
What is the cosine of 90 degrees?
Zero.
Bottom of the table, it's 0. Okay, cosine of 30, think special angles,
It's going to equal
second row, cosine
somehow.
of 30 is square root of 3 over 2, which means the cosine of 60 is it's the opposite, it's 1/2.
That doesn't look like 0.
That doesn't look like that comes out to be 0. So, the point is this cosine times 30 plus 60?
Yeah. No.
How do you say that?
Cosine of 30.
That's the cosine of 30 plus 60. So, that is not times. You can't distribute a trig function times an angle. That's not what we're doing here. Illegal. But can't happen. So, instead, we had to have what they call the sum and difference identities that tell us what do you do if you have two different angles. Now, in our case, most of the time, we're going to be working with variables on our angles. We don't know what the angle measures are. Yeah, obviously, in this case, yes, you could just crunch the numbers, but normally you're not going to have that. So I want you to look, if you flip to the back side of your yellow sheet, you will see all the sum and difference identities. And it tells you how to do the cosine of two angles that are added, two angles subtracted, sine, and then tangent for each of those angles. Okay. However, for me to prove this to you, it would take me about 15 minutes to prove one of them.
Good, so put 1 on the thing.
Approve?
No, oh no, it's good.
Okay, so I don't. So if you're really, really, really dying to know how they came up with this incredible formula, read pages 202 and 203. It basically comes down to the distance formula with trig functions in it. To give you a shortcut version of it. But at the moment, I'm going to prove it to you numerically, not go through the whole 15-minute proof. So what the identity says is, if you have the cosine of A plus B, the yellow sheet says do what?
You do cosine of A and cosine of B.
Okay, so it says take the cosine of both each angle.
Minus sine of A and sine of B.
Okay, so if we go back and do that here for our 30 plus 60 thing, that's saying I should be doing the cosine of 30 degrees times the cosine of 60 minus the sine of 30 degrees times the sine of 60. Okay, well, if you still special angle values in there, we still know this has got to equal 0. But this is going to be, we already did these first two. We know that's square root of 3 over 2 times 1/2. And if you do sine of 30 is 1/2 and square root of 3 over 2. They're the exact opposite. So isn't that going to be 0?
Yeah.
Yeah, so it works. Wild and crazy as it is. So those are your sum and difference identities. Now, there are actually all 6 of them on there. I'm going to write them out to the side here. So for those of you who are watching the video, if you don't have an identity sheet, you would need to get a copy of it, which is the identity sheet is posted on the website always. If you need it, it's there. But I'm going to list them out here so that we can actually see them and look at them as we're using them. There is a pattern to each set. You don't have to memorize them, but sometimes it's helpful to notice the pattern. What's the difference between the cosine A plus B and the cosine of A minus B identity?
Get out of plus.
It's always the opposite sign. If you're subtracting, then the identity will have a plus sign in the middle. So those two are, it's just the opposite sign. The cosines always come first. The sines always come second. Okay. Well, if you notice the sine identity,
When it goes plus, it's going to be plus.
when it's plus, it stays plus, but it mixes up the sine and the cosine. It does the sine of one angle times the cosine of the second angle.
And then switches that.
plus, then, yes, switches it. You got the cosine of A and the sine of B. It switches them up. So there actually are patterns. They're not hard to memorize if you really want to memorize them. And so then, of course, when I do the minus identity, I'm just going to change it to a minus in the middle. Now, some people look at the tangent identities and think, it's horrible, I can't keep it straight. Nah,
It's not that odd.
it's not that bad. It's always on top. If you're doing tangent of A plus B, it's the tangent of A plus, keeps the same sign, the tangent of B.
And then it's.
But on the bottom, it's always 1 minus, it'll be opposite sign. If the top was a plus, the bottom will be a minus. And you'll have tangent of A times tangent of B. So at least it always keeps tangents in it. That's one good thing. So if you do the A minus B, it's the exact same thing with just the sign switched. On top, you'll have the minus, and on bottom, you'll have a plus. So now, that tangent one, we don't use it tons. The sine and cosine ones come up in several different places throughout trig, and occasionally we run into those in calculus. They become very handy to have those. So the sine and cosine of A plus B's and A minus B's are pretty useful. Tangent, don't see it near as much. Okay, so your problems, you're going to discover here for the next couple of days, your problems, your assignment always has a pattern. The first few problems will be true-false. Can you simply use the identity, look at the identity, and tell if it's being used right or not? So, for example, if I do a true or false here, would the sine of 70 degrees equal the sine of 20 degrees times the cosine of 50 degrees minus the cosine of 20 degrees times the sine of 50 degrees? Okay, well, Cody, it may look long, but it's just one of those identities. What I recommend is you look at the right-hand side and go, which identity is that? A sine times a cosine minus a cosine times a sine. It's got the minus in the middle, so yeah, it's the sine of A minus B identity. So just ask yourself, okay, if this is the sine of A minus B, what is angle A? Angle A is 20. What's angle B? 50. Okay, is that going to equal the sine of 70? No. That is not going to work. Sine of negative 30 is not the sine of 70, so therefore, it's false.
Okay,
this part is not hard at all.
If that was true, would you have 30 backside too? Check that.
If it was true, you'd get sine of 70 equals sine of 70. It would come out.
Have to do the minus.
Yeah. When you did this, actually, what would I have to change to make it true? One tiny change would make this a true. If that was a plus sign in the middle, I'd have been doing 20 plus 50. It'd have worked. If I just had a plus sign in it, it would have been true. So that you're saying that didn't blow you away? Okay, here's one other one. True or false? Tangent of 110 degrees equals the tangent of 80 degrees plus the tangent of 30 degrees all over 1 minus the tangent of 80 degrees times the tangent of 30 degrees. So, I heard tangent of A plus B. We think that's what identity is because it's got a plus on top, a minus on bottom. And so if I would be adding the angles, which means I would be doing 80 plus 30. And I do believe that equals 110, doesn't it? Am I down all the way? I'm down all the way. And so, they're equal, that's true. Okay, so we can handle true false. Now, next one. Alright, this is neat. One of the big things you're going to start to be hit with a lot, well, since most of you are juniors and seniors, maybe not so much, probably you'll see a little of it. One of the big new emphasis with the Common Core Standards is to teach you academic vocabulary, that you have the understanding of the terms that are used in a subject area and know what they mean. Could you be quiet by any chance? I'm sure they can hear you more on the video than me. Okay? By this point in your mathematical lives, you should know what the word evaluate means in terms of math problems.
Pretty much,
What kind of an answer should you get if it's an evaluate?
number.
A number. It has the word value in it. If it says evaluate, it means come up with a numerical value of this expression. I'm going to give you an expression. You have to tell me what number it equals. But this time, I'm going to throw you a problem with everybody's favorites in it, radians. We can't forget either one. So, it's the same exact thing we just did. You look at that and go, does that look like any of these identities?
It is sine A minus B.
Sine A cosine B? So yeah, it looks like sine of A minus B, doesn't it? So we would go, oh, alright, if that's the sine of A minus B, then what's A and what's B? A is
Sine square.
B is pi over 2. And so literally, solve it out. What's 5 pi over 4 minus pi over 2? How do you subtract that? So that'd be like 5/4 minus 4, or yeah, minus 2/4. 5/4 minus 2/4 would really be 3/4. It's just that we have a pi with us. So I need to know the sine of 3 pi over 4. Oh golly gee, look at those special angles back again. How do I do the sine of 3 pi over 4?
Do the little thing.
What quadrant is 3 pi over 4 in? The second. Look at the clock. 3 pi over 4. That's not a whole 1. That's not 1 whole pi yet. 3/4 isn't. But it is more than half. So we're in the second quadrant. The reference angle is pi over 4. So we would be asking, what's the sine of pi over 4?
45.
Oh.
Cody, take your stuff, come sit in this chair. I'm tired of y'all. And I'm sure you're causing Tim to not learn either.
Listening.
Square root of 2 over 2.
To a degree.
Square root of 2 over 2. And then what's the other thing that you want to do that will not cost you half a point? Yeah, positive or negative in the second quadrant. Sine. Sine is positive in the second quadrant. So, but you do need to check that. So, notice our answer is a number. We got square root of 2 over 2 as an answer. So you get value, we'll get value. Yes.
You were talking about the plus and the negative. Do we need to put the plus sign if it is? Or can
No, you don't need to write plus signs, no.
Okay.
I'm just writing it to remind you to check.
Okay.
But yeah, all-star trig class never, ever goes away. Ever. It will be your friend for life. Okay, so was that incredibly difficult? So you're ready for the really fun ones. I love these.
You just said that was
Still
difficult.
more evaluating.
This is not. Well, it's kind of, well, I'll just spell it out for you. It's going to say find cosine of A plus B or sine of A minus B, whatever. In this case, we're doing cosine of A plus B. And they're going to give you some information. They're going to tell you the tangent of angle A is negative square root of 5 over 2. They're going to tell you the cosecant of angle B is negative 3. And then they're also going to tell you that you know angle A falls between pi over 2 and pi. And you know that angle B falls between 3 pi over 2 and 2 pi. And that looks like a ton of information. But I want you to find the cosine of A plus B. Oh, thank you. Good place to stop. I should have stopped sooner.